Today I will be showing you how to make a Windows bitmap file using only a hex editor. I will be using Notepad++ as my hex editor and Notepad for any general notes. So first we'll start with the file header, which is 14 bytes. So these bitmap files will start out with these two hex values. As you can see in the dump, the ASCII equivalent of these hex values is BM. This lets a program reading this know that this is a BMP file. The next 4 bytes are the size of the file. Since I've already pre-calculated this, I'll put it down. And I'll show you how to calculate this later. The next 4 bytes are reserved for applications that create bitmap files, so we'll just zero them. The next 4 bytes are the offset. This will show where the color data actually starts. Since I'm going to be using the Windows bitmap info header, which is 40 bytes, and the file header is 14 bytes, I'm going to be starting at decimal 54, which is equivalent to 36 hex. The last thing in the file header is the size of the next header, in this case, the Windows bitmap info header. As you can see, it's 40 bytes, which is equivalent to 28 hex. Now for the bitmap info header. The first two things, 8 bytes, are the width and the height. For the purposes of this demonstration, the width will be 6 pixels, and the height will be 3 pixels. So let's put that in. Right. The next 2 bytes are the number of color planes, which is always 1, so just that. It takes up 2 bytes. The next 2 bytes are the bits per pixel, or the color depth. Since bitmaps store colors in BGR format as opposed to RGB, so blue, green, red, and each one is 8 bits, so 2 hex values, 4 bits per hex value, so 8 bits per. 8 times 3 is 24, or 18 hex. The next 4 bytes shows the compression method. Since I'm not compressing, it's just 0. The next 4 bytes show the image size. So this is the size of the color data in bytes. I'll show you how to calculate this later as well, but for now, just go along with me. The next 8 bytes are the horizontal and vertical resolutions. This will determine how the printer will print the pixels. So we'll just pick C5. So the resolutions are 197 pixels per meter in this case. Next up, we have the number of colors. I'm just going to use the default value 0, which makes the number of colors 2 to the n. Last thing in this header is the number of important colors. I'll also use the default, which means that there are no important colors. So as you can see, we're now at address 36 hex, which is what I've set up here. So we're on the right track. So now we can actually start doing colors. So I'm just going to put the colors can be between 00 through FF, or 255 decimal. But I'm just going to stick with zeros and FFs. So those are the first 6 colors. Pixels. Pixel 1, Pixel 2, Pixel 3, Pixel 4, 5, 6, you get the point. So before I go any further, I should tell you something. The color array must always be a multiple of 4 bytes. So to calculate the row size, Now this formula looks complicated at first, but it's pretty simple once you think through it. Alright, so let's see what we already know. So, the bits per pixel, as I've stated, is 24 decimal, or 18 hex. Our width is 6 from above. We add 31. Divide the whole thing by 32. Floor, multiply by 4. I'm just going to simplify everything inside the floor. So that gives us this value. In case you don't know, floor always rounds it down. So 5 times 4. So therefore our row size equals 20 bytes. Now, what do I have right now? I have 6 pixels and 3 bytes per pixel. So I have 18. So the next 2 bytes must be padding. Now, padding is not actually read by the computer, so it can be anything, but I'll just use 0 since that's the default value. So now I can move on to the next row. My bad. Wants to be that. So now we need padding again, and then our final row. And then padding. So now let's verify using what we know in the file already. So the size of this is supposed to be 72 hex bytes. So since we go from 00 to 71, that gives us 72. So we're good there. So now we'll verify this number here, which is the size of the pixel array size. So to calculate that, you just do row size times the absolute value of image height, since image height can be negative. So we have 20 times 3. Absolute value of 3, but 3, really. So the pixel array size is 60 bytes. Does 3C equal that? C is 12 in hex. And using my calculator, it is 60. So we're good there. So now, alright, so earlier I said that I'd tell you how to calculate this. All it is the size of the header sizes, plus the pixel array size, since those are the 2 main components. So the first header was 14, the second one was 40, and our pixel array size is 60. So therefore our file size should be 114 bytes. Does this match up with what I've put here, 72? Using my calculator, it is indeed 114. So we should be all good with this. So now let's save it. As a bitmap. So it reverts back to normal stuff. So as you can see, it doesn't make much sense, but we'll keep it back in hex. So now let's pull up Paint. And our how-to. So when we zoom in all the way, you can see it is indeed 6 by 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. So, if you analyze the color data really quickly, you notice that we start off with 0, F, 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 F. This means no blue, lots of green, lots of red. Green and red make yellow, so we're obviously not starting at the top left. Instead, we're actually starting at the bottom left. As you can see, the next color is lots of blue, lots of green, no red, so that makes cyan. Yellow, cyan. And this keeps going until you reach the end. So that's how you make a Windows bitmap file using only a hex editor. Hope you'd enjoyed it.